Today's daily LeetCode problem of the day is sort an array, number 912. For this problem, we're given an integer array nums, and we want to sort the array in ascending order and return it. We want to solve the problem without using any built-in functions and time complexity of O of n log n, and with the smallest space complexity possible. The perfect solution to this problem is a heap sort. However, I don't know how to do that, so we're going to do merge sort. Instead of an O of 1 space complexity, it's an O of n space complexity, which isn't too bad either. So how do we implement merge sort? Merge sort is a divide and conquer algorithm. So first thing we're going to do is divide. We're going to split our array into two halves, recursively sort each of those halves, and then we're going to combine those two halves. So how exactly do we do that? First things first is we're going to need a recursive method to sort, and a recursive method, or not a recursive method, sorry, a method to merge the two arrays that we sorted. So how do we implement this? First, we want to divide our array. So we're going to find the middle index of our array, and based off that index, divide the initial array into a left half and a right half that we will then recursively sort. So that comes to step 2, recursively sorting. We want to reapply our merge sort to recursively sort both of these halves. And then our third step, we want to merge the sorted halves. So we're going to create temporary arrays to hold our values, and then compare the elements of the two halves to merge them into a single sorted array. So let's get to the code. First things first is let's call to our merge sort method. So merge sort. And for a merge sort method, we pass three things. First thing is our integer array, so nums. And then we're going to pass the left pointer and the right pointer. Our left pointer is going to be the initial index, and our right pointer will be the final index. So the initial index is 0, and our final index is going to be nums.length minus 1. Then, because nums is an object, it will be modified in the functions we pass it to, so we can simply return nums. So now let's initialize our merge sort function. This is going to be a recursive function, and it's not going to have any output, so it's going to be a private void merge sort. Merge sort is going to receive three things. First is an integer array. Second is an integer left pointer. And third is an integer right pointer. Because this is recursive, we need a base case. Because we have a left and right pointer, we want our left pointer to always be less than our right pointer. That makes sense. We want the left pointer to always be on the left side and the right pointer to be on the right side. So that's our base case. As long as left is less than right, we can continue recursively sorting. So how do we recursively sort this? First thing we want to do is identify our middle point. This will allow us to separate the arrays into two halves to then recursively sort. So integer middle will be equal to left plus right divided by 2. Now that we have our middle point, we can separate this initial array into two halves, a left half and a right half. So we're now going to merge sort. This is the recursive call first time for the left half. We're going to pass our array. We're going to pass left as our left pointer and middle as our right pointer, effectively cutting this array in half. Then we're going to sort the right half, so we're going to merge sort. We're going to pass array. Then we're going to pass middle plus 1, because middle is already being addressed in this left half, and our right pointer. So this will recursively sort these two, but how is the sorting done? That's going to be done through a merge method. So we could, it's going to be done through our merge method. So we could call to our merge method, and our merge method is going to receive 4 values. It's going to receive our array, it's going to receive our left pointer, our middle pointer, and our right pointer. So let's initialize this other function. This isn't going to be another private. It's not going to return any value, so it's void, and it's going to be called merge. So private void merge receives an integer array, integer left, integer middle, and integer right. So how does this sort exactly? This is going to sort by taking the left half of the array and the right half of the array, no matter what size they are, and depending on what the value is in the array as we increment through it, we're going to add it to our nums array in the required index. So how do we do this? We're first going to find the sizes of two sub-arrays that we are going to be merging. We're going to create temp arrays for them, for these two sizes. We're going to then copy our data to our temp arrays so we don't lose the values. We will then merge our temp arrays. And then we will copy remaining elements from either array. Seems complicated, but pretty simple in the long run. So we're going to initialize our integer left half. It's going to be of length middle minus left plus 1. So that's the length of our left half. Then we're going to have our right half is going to be right minus middle. So we found the sizes of our two subarrays. Now we're going to create our temporary arrays. So int L, we can call it big L, is equal to a new integer array of left half. Integer R is equal to a new integer array of right half. Now we want to copy our data into these temp arrays. So for int I is equal to 0 as long as I is less than left half I plus plus. Then we're going to simply traverse our input array and add whatever values are from I to left half in our input array into our left array. So L of I is equal to ARR of L plus I. Then we want to do the same thing for the right half. So for int j is equal to 0 as long as j is less than right half. We're going to want to pre-increment these variables. So instead of I plus plus, it should be plus plus I and plus plus j. And then we're going to do right of j is equal to ARR of middle plus 1 plus j. Using pre-increment or post-increment doesn't really change anything, it's just more of convenience. So after we identify our left half and our right half, after we identify or initialize a left and a right array, we then populate this left and right array. We then want to merge the two arrays. So how do we do that? To merge the two arrays, we first need to initialize a couple variables. We're going to initialize an integer I, an integer j, and an integer k. So I is going to be associated with our left half, j is going to be associated with our right half, and k is going to be associated with our original array. So I will increment when we take a value from our left half, j will increment when we take a value from our right half, and k will increment every single time we add a new value to our array. So while I is less than the left half length, and j is less than the right half length, we will check if the left half of I is less than or equal to the right half of j. If it is, we will add the left half of I to our array of k. Otherwise, we will add our right half of j to our array of k. So if left of I is less than or equals our right of j, then ARR of k will be equal to left of I. Then we can increment I. Else, then we will do ARR of k is equal to right of j, and we can increment j. And either way, we will be incrementing our k value because we placed a variable in there. So this will sort our two arrays. It will sort our left half and our right half. It will go through until one of them reaches their breaking point and add them to our array in the kth position. Now, what do we do if, per se, our right half was the only one that got numbers drawn from it and there are leftovers in our left half? We are going to do a while loop to empty out the halves. So while I is less than our left half, ARR of k will be equal to the left of I will add 1, k will add 1. Same thing for the right half. So while j is less than right half, ARR of k is equal to right of j, k plus plus, j plus plus. And that is it. That is our merge sort. So if we run this, pass our test cases, and if we submit it, passes all solutions. So let's do this in Python. So this problem is similar in Python. We're going to have a merge sort method and then return our nums. So we call to self.merge_sort, but we're only going to pass our nums for this function, and then we're going to return nums. Then we're going to define a new function called merge sort. It's going to return self and nums. So how is this going to work? So the base case for this function is going to be if the length of our array is greater than 1, we will continue on. So to identify the midpoint, we are going to do mid is equal to the length of our array divided by 2. Make sure you use 2 slashes. Then we're going to identify our left and our right array. So we're going to do left is equal to, in Python it's much easier, so we can copy over the nums array by doing let's just change this to array of, we're going to do the front half to mid, and then right is going to be equal to ARR of everything after mid. And it's as simple as that. We're then going to recursively call merge sort self.merge sort on left and self.merge sort on right. And then we are going to do the actual sorting process. So I is equal to j, which is equal to k, which is equal to 0. And while I is less than the length of left and j is less than the length of right, we're going to do if L of I is less than R of j, then we will add ARR of k will be equal to L of I, and we will I plus equals 1, else ARR of k will be equal to R of j, and j will plus equal 1. And then we increment k no matter what, so plus equals 1. Now we want to make sure we check that no elements are left behind. So while I is less than the length of L, ARR of k is equal to L of I plus equals 1, k plus equals 1. While j is less than the length of ARR of k is equal to R of j, j plus equals 1, k plus equals 1. And that is it. So if we run this, passes our test cases, and if we submit it, passes all solutions. Thank you. Follow for more daily LeetCode solutions.